Hello students, welcome to this lecture. So in thermodynamic chapter, so in this video I'm going to discuss about the adiabatic process and the work done in adiabatic process. So in the last lecture I discussed about isothermal process, and also I discussed different types of thermodynamic process and find the expression of work done in isothermal process. So in this video I'm going to find adiabatic process, work done in adiabatic process, and also isochoric and isobaric process. So this is my lecture 5. So to understand this lecture more properly, you must follow all the previous lectures related to my thermodynamics. So what is adiabatic process? What is adiabatic process? So adiabatic means dq is equal to constant. It means in that case there is no heat flow into and out of the system. It means there is no exchange of any heats. It is a insulating type of things. Okay, so this is the adiabatic process. If you consider this diagram, you can see there are two graphs. One is isothermal graph and another is adiabatic graph. Okay, so I think you remember in isothermal lecture I said that there are two conditions. One condition related to the isothermal is that the process is slow. Okay, same here in adiabatic, the process is rapid or fast. So if you see the diagram, so you find that the process, this curve is quite slow. It is not that much sharp. So that's why this process is slow. But here we observe that that curve is rapid and sharp. So related to this condition, we get this kind of graph. Why? Because the isothermal process is quasi-static. It means it is a slow process, and the adiabatic is the first process. That's why we can get the sharp slope. Okay. Now, what are the condition in the adiabatic? Condition in adiabatic process. So adiabatic process means our dq is equal to constant, and the condition 1 is non-conducting. It means insulated. It means there is no exchange of any heat. In our isothermal, the process is conducting. Here it is non-conducting, and the second is quick or rapid process. That already we say that quick and rapid process. So to get the adiabatic system, we need two conditions. One is it is a non-conducting, and another is it is a rapid and the quick process. And also our dq is equal to constant, and our other variables p, v and t may change in our adiabatic process. Okay, now what is the equation in adiabatic process? We can write it here. Pb to the power gamma is equal to constant. Okay, so this is equation of adiabatic process where gamma is the value of Cp by Cv for that gas. Okay, so one important point is that already we said in the last lectures that this process, this adiabatic and this isothermal, all must whatever the expression we are going to find, this must be valid for our ideal gas only. So this is for the ideal gas equation. Okay, so now the most important task is to find the work done during adiabatic. So this is quite important topic, and you need to understand this work done. So first, in isothermal also we discuss the work done, and in adiabatic we are going to find the work done. So first we can write, we know that work done during a process. So we know that dw equal to p dot dv. Okay, so or we can also write w equal to in the integral form. So one more important thing is that to get the work done, one very important condition is that its volume must change. So here the volume changes from Vn to V2, and also in the isothermal process our volume is changes. If there is no change in any volume, then we are not getting any work done. Okay. So now this is in adiabatic case, that's why you can write in adiabatic we know that formula Pv equal to constant. Okay. So in equation 1, P equal to, we can write constant by V to the power gamma. Okay, so now put this value P in this equation. So now we are going to put the value in equation 1. Therefore our W equal to V1 by V2 constant dV by P to the power gamma. I think you understood up to this. Okay, now next constant we can write is V1 V2 P to the power gamma into dV. The next we can write constant, and I can write V1 minus gamma by 1 minus gamma, and we can write it V1 V2. So how we get this? From integral formula, x to the power m, we can write it like this: x to the power m plus 1 divided by m plus 1. Using this formula we can get this expression. Okay, now constant, just I can keep it out. We can write V2 1 minus gamma, V1 1 minus gamma. Therefore we can write W equal to 1 divided by 1 minus gamma P2 V2 V2 gamma minus 1, and P1 V1 gamma minus 1. You see earlier this is 1 minus gamma, but now it is gamma minus 1. Why? Because if it is symbol, then this is like this, P to the power minus gamma. So I can write like this, P to the power gamma. Okay, and the constant is already, we know that the constant value, so Pv to the power gamma. So we can write this constant value in there. So this W is equal to this value. So this is the simple mathematical expression. I think you understood all this line. Now in the next we can write 1 minus gamma P2 V2 minus P1 V1, then 1 minus gamma mu r T2 minus T1, and we can also write mu r gamma minus 1 T1 minus T2. So how we get this value? We know that Pv equal to mu RT. We already said that this is for ideal gas. So this is our expression, work done in adiabatic process. Okay, So this is the formula for work done in adiabatic process. So this expression is quite important to get our next Carnot cycle. Okay, so I think you understood this expression. Now we are moving to the next point, and the point is the isobaric and isochoric process. So what is isobaric? Isobaric means our pressure constant in that case, and isochoric is the volume constant in this case. Okay, so there are two graphs. One is pressure constant, another is the volume constant. So now in this next we are going to find the work done. So is it possible to find the work done in isochoric? So what is isochoric? So I am writing here. Isochoric means volume constant. So if there is a volume constant, so there is no work done. So that's why we are not going to find the work done in isochoric process. But we can get some expression. So according to the first law of thermodynamics, you can write mathematically, you can prove this. du plus dw, we can write du plus pdv. So in isochoric, what happened? Or dv is equal to 0. It means our this part is equal to 0. That's why there is not work done. So we can write it du equal to du. That means complete heat is used in rising temperature. It means whatever the heat we can apply is just used to rise the temperature, but we are not getting any work in our isochoric process. Okay, so this point is important. Complete heat is used in raising the temperature, because to get some work done we need some change in volume. But here what happened in isochoric process, there is no change in volume, so we are not getting the any work done in isochoric process. Now next is isobaric process. Isobaric. So isobaric means pressure constant. Pressure constant. So we can write this value. Pressure is constant, so V2 minus V1, volume may change. We can also write this term T2 minus T1. So we can write dq equal to du plus W. So here we can see there are two terms. There are two W term. Okay. So what is the meaning of this? We can write it here. Heat given is divided into two parts. So in isobaric our heat is divided in two parts. Some parts or energy is used in work done, and rest of the heat energy is used in change of temperature. You see this one part, this part is basically to change the work done because the change in volume, and this part is basically for the change in temperature. So I think you understood all this four process and the work done in isothermal and adiabatic process, and this work done for adiabatic and adiabatic and isothermal process are very much important. If you have any doubt, then you can comment me, and in the next video we can going to find discuss the reversible irreversible process and the second law of thermodynamics. So for this video, up to this, I think you have understood, and thank you for watching.